All right, in the next few lectures, what we're going to be doing is taking a look at a system or systems that combine a lot of the aspects of heat transfer that we've been looking at thus far in the course. And the topic that we're going to look at are heat exchangers. And heat exchangers are very interesting. There are many, many different types that exist, but essentially what we're doing is we're transferring energy, thermal energy, from one fluid to another fluid. So that is the way to describe what a heat exchanger is and does. Essentially what it does, it transfers energy, remember I said thermal energy, between two fluids at different temperatures, and we need to keep the two fluids apart, and consequently they're separated by a solid wall. Now, heat exchangers are used all over the place. We use them in many, many, many different types of engineering systems. And so let's take a look at a few different types of heat exchangers. But before we get there, applications of heat exchangers could consist of the following. And this is just a very limited subset. So power production, that would be anything from a Rankine power plant to internal combustion engine, even a Stirling engine, any of those cycles. It also is used in space heating. So heating of buildings or homes, and air conditioning. So cooling of spaces. It's used for refrigeration. And another example, chemical processing. So we use heat exchangers in many, many different engineering applications. And what we're going to do now, we're going to take a look at some of those applications, and we'll also take a look at a couple of different designs of heat exchangers as we go through and look at these next set of images and videos. So what we're going to do, we're going to begin with transportation and automotive transportation. And this is an old car from 1893. It's a quadricycle by Peugeot, and it was one of the very early gasoline-powered automobiles. But you can see there's a heat exchanger behind the wheel. And when you zoom in closer, that's another view of the heat exchanger by the front wheel of this Peugeot automobile. This is the Vis-a-Vis. It is another car. It was produced in France by Dion and Bouton, but when you look at the front of it, you can see something that looks like a heat exchanger, and sure enough, that is a very, very early radiator, similar to what we saw on the Peugeot. And there are the fins on the radiator. They're a little bent with time, but this is from 1899, and this speedy looking vehicle, this is a Ford Model T, and you can see the heat exchanger on the front. Ford, in a period of 20 years, starting in 1908, sold 15 million of these. And so automobiles were all over. And as you can see, today we do have automobiles everywhere. And this is rush hour, early morning. If you look at the front of the vehicles, you'll see kind of a lighter temperature that signifies heat. That one doesn't have a lot of heat in it, but there are some that do, and that would be the location of the radiator that we have in the vehicles. So anyways, you can see the progression and the use of heat exchangers in power production of automobile applications. because any power cycle we always have to reject some of the thermal energy, and we often do that with the heat exchanger. Now, moving on, I talked about air conditioning and refrigeration, so let's take a look at those applications. And here we can see a refrigerator. This is one that has the compressor and the heat exchanger in the bottom. You can see the IR camera. There's a fan circulating air. So that's a fluid to air heat exchanger. If you've ever stayed in a hotel, I'm sure you've heard this all night long. This is a heat pump, either heating or for cooling inside of a hotel room, and it'll cycle in and out throughout the night. There are heat exchangers within there to cool the air that is going through that. This is a larger type of heat exchanger used for refrigeration or cooling applications, air conditioning, and you can see the heat exchangers are at an angle. This is a view of Tokyo. And if you look down any large city, you'll find heat exchangers. These are the cooling systems used for rejecting the heat from the air conditioning for large buildings. And so that would be industrial applications that we have of both refrigeration as well as air conditioning. Now what we're going to do, we're going to go into industrial applications, and we're going to begin with the aerial coolers. And so the aerial coolers are, you have air on one side, and you could have a processed fluid or something else on the other. Could be a gas, but the aerial cooling units begin with tubes, and there we can see the tubes lying ready to have fins placed on them. This is what fins look like before they're put on the tubes. They come in big rolls. They're unrolled, and there you can see the fin coming out. And it is fed into a machine. You can see the tube spinning in the foreground there, and there's the tube spinning. The fin comes in, and then it is wrapped around the tube. And so that's the process of putting fins on tubes. And there you can see the tube coming out that has the fins on it. And then after doing this with many different tubes, you get things that look like this. And there you can see the fins on the tubes, and then a big stack. And these would all be used, and eventually they would go into the aerial cooling units. And so that is what the thin tube looks like. And those ultimately get attached to header boxes. And so here we can see a procedure whereby the tubes are being welded to the header box on the inside. And so this is a special welder that can go in and do a circular weld on the tube inside of the header box, and a very skilled practice in order to do that welding. As you can see, this welder performing the practice there, and sometimes the tubes are expanded, and so here we have a tube expander, pneumatic driven, and each of the tubes inside of the header box is expanded, and that's the way that it is connected. And so for the aerial cooling units, we attach the tubes with the fins to the header box, and then this is what it looks like after. And here's an image of it being pressure tested to ensure everything is up to quality specifications. This is where it eventually goes. These are the fans that will circulate the air over the heat exchanger. You put it all together, you put it on a truck, and you transport it to the field. And so here you can see aerial cooling units being assembled. And they could be high, they could be anywhere within where the chemical engineers put them, and the mechanical engineers have to deal with it. And then this is an aerial cooling unit at a compressor station, and again you can see all of the different units like we saw being fabricated. So that is petrochemical applications or chemical processing, where we have aerial cooling units. Now, another form of heat exchanger that we're going to look at in the next few lectures is the shell and tube heat exchangers. So let's begin by looking at that. So here we have a model of a shell and tube heat exchanger. You can see the baffles in the front. And so the baffles are what the tubes are going through. And then at the end there are tube sheets. So there is the tube sheet, and there is a baffle. The baffles are partially cut for the fluid to go around that is within the shell. And there you can see all the tubes together with the baffles and the tube sheet at the end. You can see again there, that's a side view of the baffles, and then that's an end view of the tube sheet with all of the tubes coming out. And then when they're done, that's what it looks like. So that is a shell and tube heat exchanger when it is completed. Now, there have been some technology innovations that have come along over time with shell and tube heat exchangers, and we'll take a look at a couple of those. The first one has to do with a spiral baffle. And so here we can see the baffles are, they're spiraled or helical. And what that does is it causes the fluid to flow around it. It would reduce the pressure drop, and it would probably reduce fouling and increase heat transfer as well. And so that is a spiral baffle that we're looking at in this image. And there we can see a closer in view of the spiral baffle. And this is M baffle, where it's a longitudinal, basically a double pipe heat exchanger. And these baffles, essentially what they do, they create a lot of turbulence and enhance mixing, again reducing fouling. So those are some of the different types of heat exchangers that we're going to be looking at. It gives you an idea in terms of where heat exchangers are used. They're used all over the place, and so consequently that's why heat exchangers are such a very important topic in a course on heat transfer. And the thing that's nice about it is that heat exchangers combine everything that we've been looking at thus far in this course. They combine conduction across the wall, we have convection, you can have condensation, you can have boiling, you can have everything going on within heat exchangers. And so they really do represent a neat synthesis of everything that we have learned thus far in the course. So we're going to be looking at heat exchangers in the next few lectures, and that will guide us through what we're going to be taking a look at. We'll look at heat exchangers. In this segment, what we're going to be doing is we're going to be taking a look at the ways that heat exchangers are classified. And so the two ways that we classify heat exchangers, we look at the way that the flow is arranged, and we'll be looking at examples of that. You can have parallel flow, you can have cross flow, you can have mixed fluid, unmixed fluid, and the type of construction. And there are different types of construction. We've already seen in the previous segment looking at different types of construction of heat exchangers. But these are the ways that we classify heat exchangers, and it also guides our analysis. Depending upon which equations we would apply, it would depend on the type of construction or the flow arrangement. So what we're going to begin with, the most simple type of design of a heat exchanger, and that's where you have two pipes, one smaller diameter than the other. They're coaxial, and you have fluid going either in parallel or in counterflow with respect to one another, and there's heat exchange between the pipe wall, between the two pipes. So let's begin looking at that. Okay, so here we have two different types of flow arrangements for what we refer to as being the double pipe heat exchanger. And in both of the figures, one over here, that is inner tube flow as well. And then on the outside, we have what we refer to as being our outer tube flow. Now, with these two, these are basically the same type of construction. The only difference is the direction of the fluid. And we would refer to the one on the left as being the parallel flow configuration or arrangement. And that is because you can see the two fluid streams are going in the same direction. And that is why we call it parallel flow. And then all of the heat transfer is taking place across this interface here and here. So that is where our heat exchange is taking place. And then the design on the right, that we refer to as being the counterflow flow arrangement. So those are two examples of the simplest, which is the double pipe or concentric tube heat exchanger. Another flow arrangement and type of construction that we have is that for cross flow. So a cross flow heat exchanger So this is a different type of construction. And this is one where what we have is a tube bundle. And so out of each of these tubes, we would have flow coming out. And then going perpendicular to that, or near perpendicular, we would have a cross flow. And for this particular type of construction, you can have fins or no fins on your tube bundle. And depending upon the type of construction, if you do have fins, you may have a scenario where the cross flow does not mix with itself. And so if you imagine if you have fins that are all connected, so if you had fins that were going like this and going across all of them, and then another set of fins, it's kind of a poor drawing. Yeah. So then another set of fins going like that, and then another one. So if you have fins like that, what's going to happen is the fluid will not be able to mix in the cross plane in terms of the cross flow. And the tube flow, obviously the fluid there is not going to mix because they are all in individual tubes. So you can have mixed and unmixed, and you can have finned and unfinned, different types of configurations for cross flow heat exchangers. But typically this one, although not exclusively, but quite often, this would be gas to liquid is what we're looking at for the heat exchange. And when I say liquid, it may not be a liquid, it could be a vapor going to a liquid. And that would be the case of condensation. And I guess you could also be going through a phase change the other way, going from liquid to vapor, depending upon the particular design. But anyway, typically gas to liquid, that is the cross flow heat exchanger. So it's another type of construction. And again, you can have different flow arrangements, just like I said, depending on if it's mixed or unmixed, if you have fins or no fins. And then the next type of heat exchanger that we're going to look at, these are heavier units that are used in many industrial applications, but these are shell and tube heat exchangers. So let's take a look. Now the arrangement is going to depend upon how many shell and tube passes you actually have. You can have two shell units sitting next to each other, shell and tube, and then you would be going through two shells there. Or the tubes, you can actually have them do multi-pass in a single unit. They're all different types of geometrical configurations that you can have for this. But let me just show you the most basic one. Okay, so what do we have here? Let's label the different things that are in here. Now, to begin with, we have fluid coming in, and that is on our tube inlet. And what's going to happen is that fluid is going to come into this manifold on the end, and it is going to be forced to go into these tubes, and then it is going to flow along the tubes like so. And you'll have hundreds and hundreds of these tubes. Well, it depends on the construction, but many, many tubes. And then it comes out and it comes into another manifold where there is some mixing, but then it goes out through this exit here, and that is our tube outlet. Now, there will be another flow coming along here, and this is referred to as being the shell inlet, because that will be on the outside. There's a shell outside of our tube bundle, which is on the inside. And the shell flow is forced to go normal or cross flow across our tube sheet. And then it comes here and it turns direction and goes around. And then it comes and it turns direction again. Oh, that's a very big section there. Typically they wouldn't look that way. I am not an artist, I apologize. But you get the idea, we're engineers, we can figure it out. Okay, so what's happening is the flow is going through like that, and then it's coming out in this direction, shell outlet. So that is the direction of the two fluid streams, and we have a couple of other things in the construction here that I would like to point out. First of all, there are these plates here. You can see two of them in my drawing. These are called baffles or baffle plates, and there are different designs that they have. Sometimes they'll have designs where it's like a helical pattern, and you get more efficient mixing that way. Because what will happen if you look at the fluid mechanics here, this is horrible fluid mechanically. You're going to have massive separation downstream of these baffles when the flow comes around, and you'll have significant pressure drop. Usually we're not worried about that much pressure drop with these units. Well, you'll have a lot of pressure drop, but you have a lot of, you'd have a big pump circulating the fluid through, so pressure drop is usually not your main concern. But nonetheless, you're going to have separated flow downstream of these baffles, and that will minimize the heat transfer that you're having in these regions here. So sometimes they'll change the baffles, different types of design in order to enhance mixing. The other thing that we have with the construction on this side is a tube sheet, and on the other side is another tube sheet. And so that is where the tubes come through, and they're usually welded to that tube sheet. In terms of the baffles, they wouldn't be, typically they're not welded. They are free to move back and forth if they need to. But you want to have the baffles there to minimize flow vibration. You can have flow vibration in these things, and it also forces the flow to go around multiple times. So that's kind of a poor drawing of a shell and tube heat exchanger, but hopefully you get the idea in terms of what is going on. So, and there we have shell flow forces the flow normal to the tubes, as we mentioned, and we have baffles inside of the unit. They support the tubes. Now, if you look at the tube sheet and you take a look at what it looks like, the tube sheet will span, obviously, the entire cylindrical of the shell, and within the sheet itself, we're going to have all these little holes drilled, and that is where our tube bundle is going to come through. And it'll go on. So that is what the tube sheet looks like. Now if you look at a baffle plate, it will not span the entire, so it will look more like this. And there'll be a cutout, and that's where the fluid comes around. But then you would have enough to support the tubes. And you'll notice that, let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4. Hey, I did this good. I did it well. You actually have a couple of tubes, or a number of tubes here that are free span. And so they are not confined by a baffle at that location. But that is to allow the fluid to get by. So if we look back at the shell and tube, you have this, and then you have this, and you have this. So the fluid is going around like that. And that's why you don't want the baffle plate to go all the way throughout the entire cross section of your shell. So that is the shell and tube heat exchanger. There is another design, although we're not going to look at it in the lectures here, but these are compact heat exchangers. So compact heat exchangers are designed in a manner where you try to maximize the contact area between the two fluid streams. And so these are ones that have very, very large contact area. You could have plates connected together with gaskets and the fluid goes between those plates. We won't be examining those, but that is another form of heat exchanger. And they're called compact because they're small in terms of how much space they take, but they're very effective in terms of transferring thermal energy from one fluid stream to another. So those are different designs or configurations, types of construction, as well as different flow arrangements. What we'll be doing in the next segment is taking a look at the temperature distributions between the fluid streams in these heat exchangers.